Radian Measure, an introduction to sinusoidal functions, the spring 2020 edition. So sinusoidal is going to be all new, and everything will end up in Schoology. So let's start with measures of angles. So angles are measured either in degrees, which you have heard of and done a lot of, or in radians, which is new. What is a radian? And we'll learn that in a sec. When rotating the terminal arm of an angle, a complete rotation, so base that just says when you go once around the circle, we know that we have 360 degrees in a circle, which means that 1 degree is 1/360th of a complete rotation. So if I started here, 1 degree is 1/360th, right? If we divide this into 360 equal little parts, each of them will be 1 degree. So not very big. And why 360? That's all just kind of arbitrary, right? I mean, somebody chose 360. It's divisible by a lot of numbers. Divisible by 2, 3, 4, 5, 6, not 7, 8, maybe 9, 10, 12, etc. So that's kind of handy that way, but it is pretty arbitrary, right? It's just like, let's split this into 360 parts. So what's a radian? The alternate way of measuring angles. Radian measure. So you can think of a radian this way. It's defined in terms of parts of the circle itself. So a circle has a radius, right, which is the distance from the center to a point on the circle. If we make this arc here, just ignore the barking dog. If we make this arc here 1 radius long, then this angle formed, by these sides, so this is a radius, and this arc length is also a radius. This angle will be 1 radian. So the angle formed that has a measure of 1 radian will be a central angle of the circle, subtended by an arc, so that means this is the arc, that is the same length as the radius. And it's developed from the formula. The arc length is equal to the radius times the angle in radians. This arc length, right, is the radius. And if this angle is 1 radian, then this will be 1 radius. Well, you think about a circle. How many radiuses are there around a circle? And if you think, well, circumference is equal to, and circumference is the distance around, the circumference of a circle is 2 pi times the radius. So the arc length is 2 pi r divided by r. The arc length for a first full circle is 2 pi radians. So 360 degrees in degree measure would correspond to 2 pi radians, right? And that's about 6.28. Okay, so a radian is a pretty big thing, right? This radian, 1 radian, there's over 6 of them. So radian is just a little less than 60 degrees. So once around a circle, 360 degrees is 2 pi radians. So if we divide both sides by 2, think of this as an equality. 360 degrees equals 2 pi radians. And then 180 degrees is pi radians. 90 degrees will be pi divided by 2. So divide this by 2 to get 90, and divide this by 2. And divide this by 2 to get 45, and you can divide this by 2, or multiply by half, and you'll get pi over 4. Radians. Now you don't have to know how to convert from degrees to radians. All we really need to know is that there is such a thing as radians, and that anything we do in the sinusoidal functions unit will always be in radian measure. So one nice thing is your calculator is always, bring calculator up, your calculator always opens in Radian mode. I just closed the calculator. So the calculator, let's set that. When you clear it, so second, 7, left arrow, enter, 2. So when you clear your calculator, the mode is always in Radian mode. And all you need to know is just don't touch your calculator. It's always going to be in the correct mode. So you never have to change it 2 degrees. Alright, so the next thing we want to do now is we want to look at the basic sinusoidal function. So just as with everything else, when we started with exponential function, y equals 2 to the x was our kind of basic function. when we did the logarithmic function, y equals log x was our basic function. Y equals x squared or x cubed, or just plain old y equals x for polynomial functions. We have this basic sinusoidal function. So let's take a moment to just look at the properties of this and to figure out what do a, b, c, and d mean in the context of this equation. All right, so here is the equation. Y is equal to a sine bracket bx plus c plus d. Now, in this, we do need some basic values. So we've got to set a to 1, and we'll set b to 1, and this is the basic sinusoidal function. So it starts at 0, right? So here's scale 1, 2, 3, -1, -2, -3. Starts at 0, goes up to 1, comes back down to 0, goes down to -1, and then back to 0. And this just keeps repeating endlessly in this fashion. If you want to think of things, real life things that we could describe by this, we could think of things like hours of daylight. So there's a median number of hours of daylight, and then it rises, it gets lighter, longer. That's the position we're in now. Winter's over. And so days are getting longer until summer, and then days will get shorter again until the fall. And then days will continue to get short till we get to the shortest day of the year, which is in winter, and then daylight gets longer again until we hit spring. And right now in the sinusoidal, we're about here. Now, of course, this would be measured in months or years, or months or days, and this would be measured in hours, like a time of sunrise or length of the day. How long are the days? So we'll have different units. Now, the basic one in radians, remember 2 pi is once around the circle, so here's 2 pi. And a sinusoidal function, think of it as being split into 4 parts. So those parts are from the middle. This line is the middle or the median or the midline. So you go from the middle, you go up to a maximum value. Then you drop back down to the middle. Then you fall to a minimum value. And then you climb back to the middle. And that just keeps repeating over and over and over again. And we'll see this as we play with some of A, B, C, and D. So what we're going to do is we're just going to play with these different values, and then what we'll do is we'll go back to the notebook file and we'll make some notes on that. So I'm just going to hit play on D and say, what is D doing? Well, the shape of the curve hasn't changed. So what the D value is doing is moving it up or down. It's basically taking the middle. So right there, that's the middle line there. And I could actually let's graph this, y equals d. So if I do that, that's the midline. And if I, again, hit D, you'll see that the middle of the graph, the midline, is moving up and down. Okay, so that's the midline. Okay, so let's stop that. We'll go back here, and we'll go to radians. So D is the middle of the graph, the midline, or another name for the middle is the median. Okay, like the strip down the middle of a road is called the median. So it's the midline or the median. It's the middle of the graph. Middle of the graph. And as D changes, so it moves the graph up or down. Up or down. Okay, next thing I want to play with, next value we're going to play with is, so I'm just going to set this back to 0. Okay, because you should only play with one number at a time. And we'll play with A. So I'll leave the middle here. I'll leave the midline here. Y equals D. That's actually the equation of the midline. And we'll play with A. And what we can see is that A makes the graph larger and smaller. And if A goes negative, the graph actually gets reflected in this axis. Generally speaking, we'll only deal with positive values of A. So I'm going to change that. Let's say we go between 0.1 and 10. Let's go to 5. So that's what we've got for a scale. And we'll do that by 0.1s for a step. So that's the size of the graph, right? Kind of its vertical size. It's like a vertical stretch for a quadratic or a cubic or something like that. So we're going to set that back to 1, just so we're back at our starting. Oops, there's our starting curve again. So A is called the amplitude. So A is the amplitude. And it's the distance from the midline to the maximum or the midline to the minimum. Or it's half the distance from max to min. Min. Okay, let's go back here. So here is the midline, and there's an A value of 1. Oops, I'm moving the whole thing. Distance from the midline to the max. We'll make A, say, 2. So the distance from the midline to the maximum, or from the midline to the minimum, again, or half the distance, so the distance from 2 to -2, that would be 1, 2, 3, 4 units, and half of 4 is 2. Okay, so I'm just going to set this back to 1. And the next thing we will play with is B. So let's see what B does. I'm going to change this so that B goes from 0.1 to, let's go to 5. Do it by 0.1, so it'll be nice and slow. Okay, so our A and our D, so our midline is 0, our amplitude is 1. So we'll look at the shape of the graph here, how far it is from here to here. And let's see what happens, won't we? Well, it's kind of like it's waving, but what's happening is we're changing the number of times that this graph repeats. So, for example, let me just stop that there. If B is 3, okay, and we're starting at 0 here, so we're split into 4 parts, right? So from the middle to the maximum is 1 part, back to the middle, down to a minimum. Okay, you don't need to know these values. Back to the middle again. That's called 1 cycle. That's the period of the graph, or 1 cycle. So a cycle is the amount of time, and by time I mean how long on the x-axis it takes for the graph to run through 1 full set of values, right? From the middle up to the maximum, back to the middle, down to the minimum, and back to the middle is 1 full cycle, or that's known as the period. And if B is 1, our period, the amount of time, or the distance on the x-axis that it takes, is 2 pi, right? Because 2 pi, remember, 2 pi radians is once around the circle. So this will be once around the circle. So the B value, what that does is it changes the period. So you note if B is 2, oops, I'll go to 2. If B is 2, then the period now is 1, 2, 3. We go through the 4 parts. The period is pi, right? We get a period in pi. And what that does is that's going to give us some information about B. So D is the midline or the median, right? I always think of the D in midline or median. A is the amplitude. It is that distance. These numbers are. This is just the midline, right? This is the amplitude. B is not the period. Not the period. but B gives you the period, so the period is equal to 2 pi divided by B. So you can get the period if you know the B value, right? And we'll look at that as we progress through the lessons on this. We'll be looking at, well, what if you have this equation? What if you know these numbers? Then what can you say about it? Based on these numbers, there's actually a lot that we can say about a sinusoidal graph. And based on the graph, there's a lot we can say about getting these numbers, right? And that's what we're going to do basically in the next couple of lessons. So the period is 2 pi over B. Now if I multiply both sides by B, so B times the period gives us 2 pi, then this also means that B is equal to 2 pi divided by the period. So if you know the period, if you can look at the graph and figure out the period, right? So just as we would do here, if I look at the graph and I can figure out the period, and we can actually go from a peak to the next peak, right? So we're saying we're going from 1/4 of pi to 5/4 of pi. What is this distance? Well, it's 5/4 minus 1/4, which is 4/4, or 1 pi. So the distance from here to here is pi. That's the period. Or what about the distance from 3 pi over 4 to, again, the next point where we repeat? So the next minimum, that's 7 pi over 4. 7 pi over 4 minus 3 pi over 4 is 4 pi over 4, which is just pi. So that's B. So let's set B back to 1, just so we'll get our period of 2 pi. So here's our normal sinusoidal curve again, right? Split into 4 parts, each part. So if the total is 2 pi, each part is pi over 2, right? And remember, in degrees, that's 90 degrees, 180 degrees, that's halfway around the circle. 270 degrees, that's 3/4 of the way around the circle, and 360 degrees, right? But we don't do degrees, right? So you should not do any questions in the book that say anything about degrees. So we have our 2 pi divided by 4, split it into 4 parts, so we know each part is pi over 2, right? So 2 pi, I don't think I can write on this, but 2 pi divided by 4, 2 over 4 is 1/2. Okay, so let's change C and see what happens. So it's not changing the shape of the graph, and it's not changing the amplitude or that. Basically what it's doing is it's shifting the graph to the left or to the right. So if let me set C to 0 again. 0. So if we look at this point here, which is at the midline, then as I move this way, it's shifting to the right, so you can see it. Hang on, we'll shift it. It's about pi units, right? So that starting point was there. Let's see if I move this, if it'll show. No. Well, yeah, you can see the point, so in gray. So there's our, whoops. Oh, that disappeared. But basically what C does is it moves the graph left or right, and that's called a phase shift. So C is a phase shift. Phase shift. Okay, and it moves the graph left or right, left/right. So D, right, in this equation, okay, remember, here's our equation. In this, D moves the graph up or down. A is the size of the graph, the vertical size, so it's a stretch. B, not the period, but we can use B to calculate the period. So if we have the B value, we get the period. And if we know the period, we can calculate the B value. And C is the phase shift. And that's not really an emphasis in this course, but we will look at a few instances of what does the value of C tell us, especially when we're looking at a particular type of graph, right? When we're looking at an application of a sinusoidal function. Because our emphasis in this course is really looking at applications of the sine function. Okay, so for today, 2 things. 1, radian measure, right? It's just all you need to know. It's another way of measuring an angle, and it's the only the only units that your calculator needs to be set in. You'll never be setting it in 2 degrees. And 2, the basic sinusoidal function and what A, B, C, and D do. Okay, and feel free to just print off these notes. So I'll have blanks of each worksheet along with notes, along with the video to go with it. And for now, that's really all there is. I'm going to see if I can stop this video. I can't find the recording. I hope it's recording. Hang on. Come on, recording.